I'll be going over the Chapter 2 Review Part 2 video. You've worked on this, or review, well, you've worked on this in class, so here's your chance to check your answers and make sure if there's any ones you had problems on to listen to the explanations. When you're writing the equation in standard form, remember standard form is ax squared plus bx plus c. So we're taking our equation from vertex form and putting it into standard form, and the first thing we work with is the squared. Well, squared means to multiply something by itself, so we're going to take x minus 2 times x minus 2, and we'll FOIL. So we go x times x, and then x times negative 2, which is negative 2x, another negative 2 times x, and then negative 2 times negative 2, which turns into a positive 4. Looking for our like terms here, I can simplify this to x squared minus 4x plus 4. Well, now we had a negative 3 on the outside, so we're going to bring that down and distribute it. If there wasn't a number there, then we wouldn't have this extra step. So we distribute it to all three parts. So I have negative 3x squared plus, because a negative times a negative is a positive, and then 3 times 4 is 12, and then negative 3 times 4 is a negative 12. Last but not least, we have the minus 5. So we attach that to the end, and we can subtract that from the negative 12. So negative 3x squared plus 12x minus 17. And this is f of x because we're in function notation. And that's the process to change from vertex form into standard. Number 2, we're simplifying the square root of 125. First thing to check is that a perfect number? It is not, so that means we start with our chart. We're looking for the prime numbers that can go into 125. And remember, primes, we're talking about 2, 3, 5, 7, and so on. Well, the first number I can divide 125 by is 5, which gives me 25. I can still divide that by 5, which gives me 5. Divide that by 5, gets me to 1, and I am done. So now, since we're talking about a square root, on the right side we are looking for pairs. Pairs, they have a buddy system, which means they're allowed to go outside and play. So the 5s go on the outside. We have 1 5 left that didn't have a pair, so he has to stay inside. So your answer is 5 radical 5. And again, remember, if you wanted to check it, type in the square root of 125 into your calculator, and then type in 5 times the square root of 5, and they should give you the same decimal answer. We have another simplify. I know this one's a little bit fuzzy to read, but you have it on your paper. 200x cubed y to the 4th. Again, always double check, see if that number is perfect. 200 is not. So we go to our chart, and I can divide that by the prime number of 2, which turns into 100. I can still divide that by 2, which turns into 50. Divide that by 2, which turns into 25. Now I have to switch what I'm dividing by, so I can divide by 5, which gives me 5, 5, 1, and I am done. So we circle our pairs, and now I'm going to move on to my variables. Well, x cubed means I have 3 x's, which means I can create 1 pair of x's. Y to the 4th means 4 y's. Well, that's 2 pairs. So now all the pairs go outside. Anything not circled stays inside the radical house. Well, I have 2 and a 5 circled, so that makes 10. I have 1 pair of x's circled, so that's 1x. And then I have 2 pairs of y circled, which means y squared. And then it's times the square root. I look for what's not been circled, which is a 2 from the chart, and our x. So here's the correct answer. Next question, we're still simplifying radicals, but this time we run into a negative sign. Well, we know if it's negative, that means we have to introduce the letter I for imaginary, because you can't actually take the square root of a negative. So I'm going to rewrite this as I times the square root of 169. Well, 169 is a perfect number. The square root of it is 13. So that means my answer is 13i. And since it's perfect, the radical, the square root, disappears. Have another square root to simplify. So we're going to first start with our chart. 256, double check that it's not perfect. You could just type in the square root of it. And if it gives you a decimal, that means it's not perfect, so we do the chart. Well, I know I can divide it by 2. So 256 divided by 2 would be 128. I can divide that by 2 again. That now turns into 64. Still dividing by 2. Now I get 32. Divide by 2. Turns into 16. Divide by 2. Now I'm down to 8. Divide that by 2 goes back to 4. 4 divided by 2 is 2. 2 divided by 2 gives me finally to 1 after all those 2's. So now we need to make sure we get every single pair of 2's. There has to be 2 in a group. So we've got the top 2, the next 2, these 2, and the last pair. What this means is that 256 was actually a perfect number. So if you had typed the square root of 256 into your calculator, it would have given you a whole number and you wouldn't have had to do the chart. Figured that was one most of us wouldn't assume was a perfect number, which is why I went through the chart. So now we do our variables. X to the 4th means 4 x's. Y cubed, oh, and there's 2 pairs. Y cubed, that only gives me 1 pair. So now remember when you're multiplying the 2's to be careful. We have 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. I have 2 pairs of x's, so x squared, 1 pair of y's. All the 2's are circled, all the x's are circled, and we have 1 little y who hasn't been circled. And there's our final answer. To figure out what expression would be equivalent to -3 plus 2y squared, we have to remember what it means to square something. And again, that's to multiply it by itself. So I'm going to rewrite -3 plus 2i twice for the square. Since there are 2 terms in each parenthesis, that means we need to use FOIL. So we're going to go -3 times -3. This is a positive 9. -3 times 2i is a -6i. Then I move on to the second term. 2i times -3 is again a -6i. 2i times 2i is 4i squared. Well, we know that whenever we see an I squared, we replace that with -1. So since my 4 is positive, when I replace this with -1, it's going to turn into a -4. 9 minus 6i, minus 6i, and then minus 4. Looking for like terms, the 9 minus 4 is 5. I also have a pair of negative 6i's that I can combine, which will make negative 12i. Real part comes first, imaginary part second, so 5 minus 12i is the correct answer. We're now being told to simplify a fraction here, and remember the problem within a fraction is you're not allowed to have an imaginary number in the denominator. We do have that, so we're going to multiply by its conjugate. And again, the conjugate is when we take the imaginary part in the denominator and we change its signs. So the 4 stays 4, but instead of plus, it becomes minus 5i. And if I multiply that on the bottom, I also have to multiply that on top. So now, since we have two terms in the numerator and in the denominator, this means we're going to be foiling. So we're going to go 2 times 4, which is 8. And then we're going to go 2 times negative 5i, which is negative 10i. We move on to the second term. 2i times 4 is a positive 8i. 2i times negative 5i becomes negative 10i squared. Moving on to the denominator, I have 4 times 4, which is 16. 4 times negative 5i is negative 20i. Then I have 5i times 4, which is a positive 20i. And last but not least, 5i times negative 5i starts off as minus 25i squared. So now let's look at what we can do to start simplifying. I know that the I squareds, where I can replace them with, once again, negative 1. So I'm going to rewrite my numerator. 8 minus 10i plus 8i. And since it starts off as minus 10, that I squared is going to change it to a positive 10. The denominator, we have 16 minus 20i plus 20i. And now another I squared. Since it's a minus 25, the I squared will change it to a positive 25. Looking at like terms on top, let's start with our reals. We have an 8 and a 10, which is going to make 18. Then we also have imaginary, negative 10i plus 8i, which will make negative 2i. In the denominator, this should always happen. The middle terms should cancel out, which they do here, negative 20 plus 20. So I'm left with 16 plus 25, which would be 41. Since we still have a fraction, the last thing to check for are the 3 numbers. So we're checking, do 18, 2, and 41, are they all divisible by the same number? The answer to that is no. So this would be your final answer. Number 8, we're now at multiplying. We're taking one term, which is 4i, and multiplying it to 3 and to minus 6i, which means we're going to use the distributive property here. Well, 4i times 3 is 12i. 4i times negative 6i becomes negative 24i squared. Once again, we run into that I squared, which we're going to replace with negative 1. So I have 12i, and that minus 24 now turns into a positive 24. Since we're gearing up for the test, remember we do want to write the real part first. So our final answer truly should be 24 for the real part plus 12i. In question number 9, we're told to subtract, and then it tells us to write it in the form where the real part comes first and the imaginary part second. Well, the biggest thing with this is we're going to be combining like terms. Anytime it's add or subtract, that's all we're doing. Before I can combine like terms, I have to take that negative sign and distribute it. So I'm going to make this a plus, which changes that negative 3 to a positive, and the positive 9i to a negative. And now I can combine my like terms. Well, the first thing I have is a negative 4, adding to it a positive 3, so that makes negative 1. Then I have a positive 4i, which is now being added to a negative 9i, and that will be minus 5i. And there's your answer for number 9. We're going to start graphing for the next couple. Remember, when we graph complex numbers, the x-axis is our real line, and then the y-axis is the imaginary part. So I look at my complex number, which is 2i, and I ask myself, is that imaginary, real, or one of each? Well, the 2 is attached to the I, so it's only imaginary. So that means on the imaginary axis, I go to where 2i would be for imaginary. Gonna make my point, and that's how we graph the imaginary number of 2i. Next one to graph, we have 5 minus i. Again, I ask myself the question, do I just have imaginary, real, or one of each? Here I have one of each, so that means I'm going to be using both the real axis and the imaginary. The first thing is, since it's a 5, I'm going to go to positive 5 on the real. So that means to the right 5. Then the next part says minus I, so that means I'm going to go down 1i, since it's just a minus 1i. So that means I went over 5, and I'm going to go down 1, which means the graph of 5 minus I is going to be right about there. Now we're told to graph the complex number negative 3. So again, check, is it imaginary, real, or one of each? Negative 3 is a real number, so we use only the real axis. Since it's negative, I'm going to go to the left. 1, 2, 3 spaces. And there's the graph for the real number of negative 3. Here the question asks us to find the number and type of solutions for x squared minus 6x equals negative 9. Well, when it asks us for the number and type, that means we're going to be finding the discriminant. Again, the discriminant is the part that falls underneath the radical of the quadratic formula. So it's your b squared minus 4ac. With the discriminant, we have 3 possible answers. If it is greater than 1, which means it's positive, we're going to have 2 real solutions. Sorry, greater than 0. Let me fix that. If it is equal to 0, then we have 1 real solution. And if it's less than 0, then we have no real solutions, which means the graph doesn't actually cross the x-axis. So our solutions would be considered imaginary. Before I can find the discriminant though, one side, just like with the quadratic formula, has to equal 0. So I look at my equation, nothing is equal to 0, so I need to move that -9. So I'm going to add 9 to both sides. So I have x squared minus 6x plus 9 is equal to 0. Well, for my discriminant, I need the letters a, b, and c. A would be attached to your x squared. B is attached to the x. And then c is the number all by itself, which in this case is the 9. So a equals 1, because it's 1x squared. B is equal to -6. And c is equal to 9. So I have b squared, which will be -6, and make sure you put in parentheses squared, minus four, that's part of your formula, times a times c. Well, -6 squared, and again, you can also type this directly into your calculator. I have 36 minus 4 times 1 times 9 is also 36. So the discriminant value is 0, which means I would have one real solution. So this problem tells us to find the zeros using our quadratic formula, which again, remember you do need to have memorized, and it's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Well, the first thing we look for is to make sure one side is equal to 0. Here, one side is equal to f of x, so we're good because we are in standard form. So we label our a, b, and c values. So a is 2 next to the x squared, b is 7, and c is 6. And now we start plugging them in. So we have x equals, since it's -b and b is 7, that makes it a -7, plus or minus the square root of b squared, which would be 7 squared, minus 4 times a times c, all over 2 times a. Now we need to take care of the number inside the square root, so -7 plus or minus, and again in your calculator you can just do 7 squared minus 4 times 2 times 6, so you have 1 underneath the radical when you do that, because it ends up being 49 7 squared minus 48 all over 2 times 2, which is 4. Well, 1 is a number that I can take the square root of, and it's just 1. So I have x equals -7 plus or minus 1 divided by 4. And this is where we're going to split it into our two answers. So our first answer is -7 plus 1 divided by 4, and our second one is -7 minus 1 divided by 4. We take the plus or minus sign and we break it apart. Well, -7 plus 1 is -6. Divide that by 4. Means my first answer is -1.5. On the other side, -7 minus 1 is -8. Divide that by 4 is -2. So here are my two answers using the quadratic formula. And again, remember, this is where the parabola would cross your x-axis. These are the solutions, roots, or zeros. This question, it asks us to find the complex conjugate. Remember, complex conjugate only deals with the imaginary part, but be careful because they put the imaginary part first here. Well, we changed the sign only of the imaginary part, so since it's a positive 16i, it becomes a negative 16i. The real part doesn't change, so since it's -9, it stays -9. They could also write this as -9 minus 16i. So be on the lookout if it's multiple choice for either answer. This would be the preferred way to write it, but it is okay if you write it the first way. Here's another find the zeros, which again, remember, is the same thing as finding roots or solving. You could do this problem one of two ways. Since it's just x squared, you actually could probably make the Santa hat work for this one if you could find factors of 18 that add up to 6. So let's think about that. If I were to do the Santa hat, it would be 1 times 18, which is 18. I would need factors of 18 that add up to 6. Well, we have 1 and 18, but that doesn't work. 2 and 9, that doesn't add up to 6. 3 and 6, that doesn't add up to 6. So this way, Santa hat doesn't work, so we do need to do the quadratic formula. So we label our A, B, and C. And we go x equals negative b, so -6, plus or minus the square root of b squared minus 4, part of the formula, times a, which is 1, times c, which is 18, all over 2 times a, or 2 times 1. So now we can start simplifying this expression. So I have -6 plus or minus, taking care of what's inside the radical, we actually end up with a negative number inside, -36, all over 2. Well, two things. First of all, we know if there's a negative underneath the radical, we're going to have the letter I, and 36 is a perfect number again, so it's going to become -6 plus or minus 6i divided by 2, because again, the negative inside takes us to the I, and 36 is perfect, and the square root of that is 6. Now, since I have real and imaginary parts, I can't put them together, but I can check for all three numbers and see if they're all divisible by the same number. They're all divisible by 2, so this equals -3 plus or minus 3i. I could put it over 1, but since 1's the denominator, that really doesn't help me out. So here's my answer to the zeros for this function. Here we have another equation we're told to solve. This time notice that it is set up to equal to 0, so we're good to solve with the quadratic formula. So we're going to label our A, B, and C. Well, A is always attached to x squared. We now only have one other term to label. It's not attached to a variable, which means it has to be our C, which means we don't have a B, so B is equal to 0. And we've seen this, I think we saw it on a warm-up problem. So we have x equals -b, well, -0 is just 0, plus or minus the square root of b squared, so 0 squared, minus 4 times a, which is 3, times 27, which is c, all over 2 times a, 2 times 3. So starting to simplify this, we have x equals 0 plus or minus the square root. Now when I type that into my calculator, and 0 squared is 0, this means I'm going to get another negative number, and it will be -324. And then on the denominator, 2 times 3 is 6. So now we need to start breaking this down. The first thing to check for is that 324. We know it's negative, so that means an I. If you type 324 in your calculator without the negative, just the 324, and then hit your square root button, this actually breaks down to an 18. It's a perfect number. Now again, if you didn't do that, you could break your chart out and divide by 2 and so on, and you'd end up with 18 as well. All over 6. Well, we still have two answers here. The 0 plus or minus we can actually get rid of. So it's like having a positive 18i over 6 and a negative 18i over 6. Well, 18 divided by 6 is 3, so we have a positive 3i and a negative 3i as our answers. So here we have 6 radical negative 62, and they ask us to put it in terms of I. Well, keep in mind this one has something outside the radical, so whatever we put outside, we're going to multiply it with this 6, and the negative inside means we're going to have the letter I. So right away I can change this problem to 6i times the square root of 62, and now I'm going to break the 62 apart. Well, 62 divided by 2 turns into 31. Well, 31 is a prime number, so all I can do is divide it by 31. I don't have any pairs, which means 62 is actually prime. So since we expressed it in terms of I, 6i times the square root of 62 is our final answer. Not as much work as probably expected. So here we're asked to write the function in vertex form and identify the vertex. Well, first of all, we had a quiz on these type of questions from 2-4. If you need to, you can look back in your workbooks. That's where the notes were taken for this. Actually, no, we took these on a piece of paper and wrote the steps down. And that is on Edmodo if you scroll back far enough. Well, vertex form is f of x equals a in parentheses x minus h, and since it's a quadratic, squared, and then plus k. And remember, h and k are the vertex, and a is your a value you'd find anywhere else. So in order to find the vertex, we're going to use that formula you have to have memorized. X equals negative b over 2a. Well, let's label our a, b, and c then. A is negative 3, B is negative 24, and C is negative 47. So putting those numbers into the formula, we have x equals, since B is negative 24, that's going to make it a positive 24, over 2 times A, which is negative 3. So I have x equals 24 divided by negative 6. So x equals negative 4. Well, remember, x in this formula is the same thing as h. So going to our vertex, we know our h value is negative 4, so we're halfway there in our vertex. So this is h. So now we need to find the other part of the vertex, which means we take our x value and we plug it back into this formula in order to find the other half of the vertex. So we're going to have negative 3, and again we're going to take out x and plug in negative 4 for it, minus 24 times the x, which is again negative 4, minus 47. In a scientific calculator, you could type this straight out. Just make sure you use parentheses. Let's go ahead and solve it by order of operations just in case. We would do exponents first. Negative 4 squared is a positive 16. We could also do this next part, negative 24 times negative 4. Well, a negative and a negative will make a positive, and 24 times 4 is 96. and then minus 47. Well, negative 3 times 16 is negative 48. So now I can just add all these together. Negative 48 plus 96 minus 47 takes me all the way down to 1. So I know that if my x is negative 4, the y is 1, and that's the other half of the vertex. Well, in the vertex form, we don't call it x and y for the vertex, we call it h and k. And the only other letter missing is letter A, which we know is the same thing here, which is negative 3. So our final answer is going to be f of x equals A, which is negative 3, parenthesis x, and remember our h, we always write the opposite of it. So since it's negative 4, it actually becomes a positive 4. Don't forget your squared. And then since k is 1, we keep that one the same, so plus 1. And there is from standard form into vertex form. Last question for the review is to solve the equation. Remember, solve, zeros, and roots are all the same thing. We're typically going to use the quadratic formula. The only problem here is that it's not equal to 0. It's equal to 24, so we have to take care of that. And we're going to take care of that by subtracting that 24. Well, we subtract it from its like term, in this case the 16. So now I have x squared minus 8x minus 8 equals 0, and we can start solving. Using our quadratic formula here, we're going to label a, b, and c. So a is 1, b is negative 8, and c is negative 8. Putting that into our formula, we have x equals negative b. B is negative, so that makes it a positive, plus or minus the square root of b squared, so negative 8 squared, minus 4, always part of the formula, times our a of 1, and times our c of negative 8. And it's all over, in this case, 2 times a, which is 2 times 1. So simplifying, we start inside the radical. So if we type that into our calculator, again, remember those scientific calculators can come in handy. So we end up having (96) inside, all over 2. Well, 96, if you were to type that into your calculator, you would notice that it's not perfect. So we're going to break out our chart here. Divide 96 by 2, which is 48. Divide that by 2, which is 24. Another 2 turns it into 12. Another 2 turns it into 6. Another 2 turns it into 3, 3, and 1. So pairs-wise, I have a pair of 2's, another pair of 2's. So we're now going to have x equals 8 plus or minus the 2 pairs of 2's. 2 times 2 is 4. The 2 and the 3 don't have a buddy, so they have to stay inside, which is 6. And then it's all over 2. Since we couldn't actually break this one apart, we're going to leave it in the square root form. The last thing we check is any number outside the radical. Inside doesn't count. We want to see if they're all divisible by a number. They're all divisible by 2. So we'll have x equals 8 divided by 2, which is 4. 4 divided by 2 is 2. We leave the radical alone. On the denominator, 2 divided by 2 is 1. We don't need to put the 1. So here's my final solution for number 20.